Here I want to start talking about functions. What are they? Why are they useful? Let's get into it. So functions are basically blocks of code that specifically they do something, right? So let's do some examples. So imagine I have some console log statement just for kicks. And I'm going to say something like, say, hello to myself. Myself. Say hello. Whatever, I could do that. I could do that multiple times, right? Imagine that I could do that just 10 times. And in computer science, we have to exaggerate a little bit so that we can see some of the benefits, right? If we just do it once or twice, it's no big deal. But if we do exaggerate just a little tiny bit, we can see some of the benefits from some of the solutions that we come up with. So let's come up with running this example. We see that we ran this, we executed this 10 times. 10 times hello gets executed. That's great. Now, this is not a function. How can we make this into a function so that we don't have to keep repeating ourselves, right? Because this is part of the drive principle. Don't repeat yourself, right? Don't repeat yourself. Says that you should try to minimize this. And what does that mean? We can create some function starting with the function keyword. We can say something like say hello. And then we can say something like console log. Well, we can just grab whatever this statement here is and just do that. Now, by the way, there's a lot to unpack here. And just to start off with, what's the name of this function? Well, let's say hello. You can say this in camel case like this, right? This is camel case. You could also, oftentimes this is the go-to. You could also have snake case. And this is something that you have probably seen me in my Python videos do, which is the Pythonic way of doing something like this. For our purposes, it doesn't really matter so much in terms of JavaScript, but we'll keep it camel case for now. And we can see that now we have this function say hello. Now, what happens with function say hello? Well, we can, by the way, there's so many things to unpack here, but I'll go in order here. So the first thing is that we have this function say hello. We can do it 10 different times, and we can call this 10 different times, right? So what can we do? We can call this 10 different times. So we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And this will get us exactly the same as we had before. Now, what is the benefit, you might be saying? Well, the benefit is that with this function calls, now we can say, instead of hello, we can say goodbye, and we don't have to tweak it in 10 different places. We just tweak it in one place, right? We tweak it in one place, and we're done. In the other example, we would have to switch or tweak every console log statement that said hello and change it to goodbye. So you could already see that the less things we have to manage, the better off we'll be. The other way to say that as well is the more things we have to manage, the less off we'll be. Right? So obviously we want to strive to manage the less things in software development as possible, because we may forget one instance, and we may forget one line or 2 lines of code somewhere sprinkled in our code, and that will introduce some side effects, some unwanted output, and that will create a bug in our program. So we don't want to do that. So kind of going back to dealing with this function, there's a lot of things to say here. So the first thing I'll say too is about hoisting. Notice that here what we did was we're invoking the say hello method, or function rather, before declaring it. So in other languages like Python, for example, you would have to do this. You had to declare it and then invoke it. And we know this still works in JavaScript, right? This still works. But the reason is because in JavaScript at runtime, whenever we run this file, this function gets hoisted to the top. This is called hoisting. It gets hoisted to the top and loaded up in memory. And then when it gets invoked, it will be ready because it's already read. It's read in memory. In Python, that's not the case, but this is not a Python video. So I just wanted to just highlight that this, in fact, you could do this way, and that's why it worked, because of hoisting. More importantly, let's continue talking about some things that go along with functions. And some of those things are, you can have you can have a first name default. Let's call that ed. Let's make it ed so that you can say, actually not here, that's not the function. I meant to do it here. And what you can say is, hey, goodbye, comma. We can make this a template string, by the way, because we know about template strings. And we can say first name goes in here, right? And we can say something like this. And this would be great. Why? Because we're not calling, we're not sending this parameter, first name, to say hello, but it should still work because we have a default parameter, and that's why we say ed. Now, if I did send something like Michael here, of course, that's not a default, so ed should not be the default, it should be Michael, and that's why we'll get Michael here. So that's named defaults, right? So that's really, really important. Now, that's all you need to know. Well, that's not all, but for now, the last thing I want to emphasize is that every function, in any programming language really, every function should have parameters being passed in, and this should return something. So maybe even this should be a return. You should return this, right? And here you should be able to say, let's call it a variable, and everything should be a const by default, like result, unless you know it's not going to be, it's going to be something that you want to tweak, and that way it will be a let, and var would only be used if you want to keep things more in the legacy realm, just to emphasize that this is legacy code. But for the most part, it should be const or let if you know it's going to change. What's going to change the value, because let does change. It does allow change. Const does not allow reassignment. So here, if you go ahead and you console log the result, we'll see that we get the same thing, goodbye Michael, and that's exactly what we want. So again, we're passing some parameter and we're returning something. That's what makes functions so powerful. You can pass different parameters, values, right, and you can return something, and that makes your function, and function should be doing one thing, and one thing really, really well for testing purposes and just for readability and maintainability. You don't want functions to be 500 lines long. You want them to be, rule of thumb for me, is really less than, than 50 lines, right? If it's more than 50 lines, that's kind of a red flag. That should be a code smell for us to go ahead and dig into. Why is this function so big? And let's break that down into smaller functions, right? Smaller problems, smaller solutions, so that they're more maintainable, easier to go ahead and navigate through, and you won't make interpretations about, as much about, hey, this 500 lines of code, I think I know what it does. Well, you're reading the 10 or 15 lines of code, right, and it's more manageable. Again, software development is all about managing complexity, and this is one great way to manage them.